Welcome back, Geomasters. Today we're diving into the subtropical anticyclones, the VIP bouncers of South Africa's weather. These high-pressure giants from the subtropical high-pressure belt, around 30 degrees latitude, control who gets rain, who bakes in heat, and who's stuck with frost. If you've forgotten what an anticyclone is, rewatch our global air circulation lesson. It's like the foundation for this topic. The three anticyclone bosses. Let's meet SA's weather influencers. First, the South Atlantic High, chill, dry, and hangs west of Mzansi. Then the South Indian High, warmer, moisture-rich, lurking east. Finally, the Kalahari High, the desert boss that rules our interior. Think of them as the big three of our climate drama. Let's break down what these three anticyclones, South Atlantic, South Indian, and Kalahari Highs, have in common. All three. 1. Sinking, subsiding air like a stubborn elevator, crushing clouds and rain chances. 2. Bring dry, stable weather, perfect for braais, terrible for farmers. Third, shift. Seasonally, they shift further south in winter but move northerly in summer. 4. Air circulation is anti-clockwise. 5. Create inversions. More on that later. Got it? Noise. Now let's meet the trio. The South Atlantic High. This guy brings cool, dry air from the Atlantic. Ever wonder why Cape Town's winters are wet but the Karoo stays dry? Blame this anticyclone. It prevents condensation on the west, letting cold fronts sneak in during winter briefly before shutting the door. Now the South Indian High, the moisture maestro. It pushes warm, humid air from the Indian Ocean onto the east coast. Durban's humidity? Thank this high. But in winter, the Kalahari High fights it, trapping moisture below the escarpment, like a sibling rivalry over the TV remote. Kalahari High, the interior's dry overlord. In winter, it's stronger than a rugby scrum. Cold air sinks, creating an inversion layer below the Drakensberg. This lid traps dry air, blocking moisture. Result? Frosty mornings and braai weather all day. But in summer, it weakens, letting moisture sneak in for thunderstorms. Seasonal shifts, winter. The Kalahari High's inversion layer is lower than your phone battery at 2%. It traps dry air, causing frost and clear skies. Summer. The inversion lifts, moisture floods the interior, and boom, thunderstorms. It's like the high's taking a vacation. I can see you there scratching your big head due to confusion. Well, don't worry, I've got you. Let's break down winter versus summer conditions in South Africa's interior, where the Kalahari high pressure plays weather dictator. First, winter. The sun's focus shifts north to the Tropic of Cancer, leaving South Africa with weak, indirect sunlight. Therefore, the interior cools faster than a fridge at night, thickening the Kalahari high like a stubborn blanket. Cold air sinks, compresses, and warms adiabatically. Yes, sinking air heats up. This creates a surface temperature inversion, warm air above cold air. The inversion layer squats below the Drakensberg escarpment, trapping dry air over the interior. Moisture from the Indian Ocean? Blocked at the coast, like a bouncer at a club. Winter results: bone-dry skies, frosty mornings, and midday braai weather. Daytime temps are mild, thank the adiabatic warmth, but nights? Colder than your ex. Farmers, good luck growing crops without rain. Transition to summer. The sun migrates south, warming the southern hemisphere. The Kalahari high weakens, like a bully losing their grip. The inversion layer lifts slightly, teasing the interior with whispers of moisture. During summer, the sun hammers the Tropic of Capricorn, turning SA's interior into a giant frying pan. Hot air rises, forming a thermal low-pressure zone at the surface. The Kalahari High retreats east, now an upper air high, while the inversion layer lifts above the escarpment. The gate opens for moisture. Moist air from the South Indian High surges over the escarpment. As it rises over the interior's heat, it cools, condenses, and boom, convective thunderstorms explode. Nature's fireworks. Summer results. Scorching hot days, blame the direct sun, and afternoon storms. Joburg's skies crackle with lightning, and dams fill faster than a minibus taxi. But don't celebrate yet, flash floods can wreck crops. Recap. Winter. Kalahari High's inversion traps dry air. Summer. Heat lifts the lid, letting storms party. Next up, moisture fronts and line thunderstorms, where these anticyclones clash. Ever seen a storm line so sharp it could slice a snail's shell? Subscribe now or miss the weather war of the century. Stay sharp, Geomasters.